In this problem, the population of the Bronx in 2020 was 1.44 million and growing at a rate of 3.4% a year. If the population continues growing at the same rate, how many people will be in the Bronx in 5 years, round to the nearest hundredth? So I'm going to annotate the key information. I notice that I'm starting at 2020. I have 1.44 million and it's growing with a rate of 3.4% per year. So my template formula is going to be 1 times a plus or minus r to the x, and I can see that it is growing, so I'm going to be adding r. From here, I'm going to look at each of the values. So y is going to be my total population. My a is my initial population. My r is the rate, which I convert to a decimal. And then the x is time, which again is in years. I don't know what my total population is, so I'm going to leave that blank, but I do know my initial population is 1.44 million, and the rate is 3.4%, which when I can divide by 100 is 0.034. My time and my x is 5 years, so then I can plug in everything I know. So y is equal to 1.44 times 1 plus 0.034 to the 5th power. And then I'm going to put that into the calculator, is equal to about 1.7 million, 1.70 million. And then my part B says, at this rate, when will the population of the Bronx reach 2 million? So I'm going to go through each of my pieces again. This time I have a total population of 2 million, so I know that this is 2. I know that my initial population has not changed. That's still 1.44 million. My rate is the same, is 3.4%. And my time is the thing that I don't know. So here, instead of y is equal to a times 1 plus r to the x, I have 2 is equal to 1.44 times 1 plus 0.034 to the x. And because I don't know what this x is, I'm going to graph y equals 2 and then y equals this whole expression and see where it takes me. As I look on Desmos, I see that there's a point of intersection right here at x is equal to 9.8 roughly. So if x is equal to 9.8 years, then, or well, round it to the near 10 years, that means that it is 10 years after 2020. So 2020 plus 10 years is equal to 2030. And so my population of the Bronx will reach 2 million in the year 2030. Let's summarize. With exponential growth versus decay, we have the same general template. We have a a times 1 plus or minus r. If it is growth, we're going to add the r. If it is decay, we're going to subtract the r. That is your decision that you have to decide from the word problem, which is why you need to annotate the key information. Once you decide whether your situation represents growth or decay, you choose which sign you're going to use, you fill out everything that you know, and you solve for what you don't.